We are in topic 3, post-harvest technology of coffee.
The sensory profile of commercial coffee is a highly engineered biochemical outcome rather than a natural accident. Final cupping quality is determined by a specific equation. 40% of the profile is dictated by pre-harvest agronomy, and the remaining 60% is established by post-harvest processing. This equation begins with the Coffea genus, a group containing more than 90 different species. Two species dominate the global market. Coffea arabica accounts for 64% of production, while Coffea canephora or robusta represents 34%. These species offer distinct chemical baselines. Arabica contains notes of chocolate, caramel, and fruit, whereas robusta yields a bitter, rubbery, and grain-like profile. Realizing the biochemical potential of these genetic substrates requires controlling precise variables across a multi-year agricultural timeline. Flavor potential begins with the age of the tree. Medium-aged trees, between 15 and 20 years old, yield the optimal balance of flavor and acidity. Deviating from this window alters the brew characteristics. Young trees yield thin, mild samples, while beans from old trees produce a harsh taste. To manage the tree's health, cultivators use pruning to modify air movement and light penetration within the canopy frame. Improved internal airflow reduces leaf drying time. This structural change actively prevents the spread of pathogens like coffee berry disease, which thrive in trapped moisture. Cultivators also employ shade regulation to control the rate of fruit filling. Literature from Garamel and colleagues in 2008 shows that shade promotes a slower, uniform ripening process. This results in larger bean sizes and improved acidity compared to coffee grown in full sun conditions. These agronomic steps secure the initial structural and chemical potential, the first 40% of the quality equation. The remaining 60% of the quality profile is determined by post-harvest processing, which centers on managing a single anatomical layer, the mucilage. The mucilage is a sticky, dense layer of pectin and polysaccharides that is highly resistant to removal by water alone. In wet processing, mechanical depulping is followed by the use of plant enzymes and microbial fermentation to degrade these polysaccharides. Stripping the mucilage in this manner preserves the inherent quality of the seed, resulting in uniform, washed green beans with minimal defects. Semi-dry processing removes the outer skin, but allows the mucilage to ferment and dry directly onto the parchment until reaching an 11 to 12% moisture threshold. This process yields a cup with less body than dry processing, but it maintains a bright cleanliness similar to the wet processed bean. Dry processing is the oldest method, where the whole cherry is sun-dried for up to 3 weeks before a mechanical process separates all the dried outer layers at once. Success in dry processing depends entirely on moisture control. Underdrying leads to bacterial deterioration, while overdrying causes the beans to become brittle and shatter during hulling. These methods function as active biochemical selections that engineer the precursor compounds of the final bean. Green coffee is chemically volatile. If the bean's potential is not protected during storage, it can degrade before ever reaching a roaster. An industrial study in Thailand tracked these storage variables in green Robusta over an 8-month period. Managing two critical metrics, moisture content and water activity, requires active aeration and air conditioning. Glucose content serves as a primary marker for green coffee quality during this storage phase. When moisture content and water activity rise due to poor aeration, glucose content increases by roughly 50% between months 3 and 6. This chemical shift correlates to negative sensory outcomes, such as woody or rubbery notes in the final cup. Elevated moisture also creates the optimal environment for fungi that produce ochratoxin A. Rigorous storage parameters protect the post-harvest investment by freezing the biochemical state of the green bean until extraction. Before processing, green coffee beans possess virtually zero flavor or aroma. Roasting functions as the vital thermal catalyst that actively forces dormant organic compounds and volatile oils to finally react. This reaction generates a matrix of up to 127 distinct sensory characteristics. These characteristics originate from specific chemical groups. Pyrazines and pyrols are responsible for desired roasted, nutty, and cocoa attributes. Conversely, specific aldehydes and esters, such as 2-methylbutanol, trigger the green or fruity notes often rejected by mass-market consumers. Each compound reaches a specific odor threshold at a precise thermal stage in the roasting process. The aromatic compounds present in the final bean are the direct mathematical sum of the entire supply chain. A perfect cup of coffee results from 40% precision pre-harvest agriculture and 60% rigorous post-harvest biochemical engineering.
Thank you. Disclaimer. Artificial intelligence, AI, was used in the development of selected instructional materials in this lesson. The use of AI is intended to enhance clarity, visualization, and learning engagement, while all academic content has been reviewed and guided by the instructor.